Hello, welcome back to the 5th episode of the Nintendo Entertainment System Emulator Development Series. I am so happy to be back. Today we're gonna continue with lots of CPU instructions. Before we begin, let me say, so the whole project is on GitHub. You feel free to browse the code. There's also, usually I'm gonna make one commit per episode. And you feel free to send pull requests, and then, feel free to mess with anything. I can review pull requests instead of an episode, or, we can do anything we want to. Second mention, let me say that I made a Discord server and a bunch of very awesome people showed up, and, we talked about their own 6502 emulator projects, physics simulation, really cool stuff going on. So if you want, go to the Discord link on the channel and, say hi if you want to. First thing, I got a comment from Robert, and he said that, or he noticed a very interesting thing that, when we use these log nest tests, we, analyze this line and we try to find where it says like P and then this value and SP and then this value. But here we try to find P, but you notice that P colon could also match SP. The only thing it works at the moment is that P comes first. So if you search for only P colon, then the first thing it will find is this. But if you find SP colon, so just by coincidence that it's P and then SP, it works. But I guess it would be a little bit more clean, a little bit nicer if you put something like space P. Then it's like very obvious that we matched the right thing here. Okay. And let's see where we even left off last time. It's also been a little bit since... Oh yeah, and last time we were a little bit confused by how jump subroutine and return subroutine work. Excuse me. So the thing with jump subroutine, and I found this here, someone asked why it returns, so it jumps to a subroutine. So basically it calls a function, you want to call this function, but it basically increments PC by 2 instead of 3. And then someone explains that this has to do, these are the steps, and this has to do with not having an extra buffer on the CPU. So basically all that means is that when you have jump subroutine, it pushes the address -1 of the next operation onto the stack, which means we basically push the address of, we still point to this C7 kind of thing, but we push it to the stack, which we do correctly because PC gets incremented here before we get into the branch, and then we increment it here and push it onto the stack. First the higher and then the lower because of little endian. And when we return from subroutine, we get it the other way around, lower and then higher. And we combine these two. And now we actually want to increase the PC, which is explained a little bit nicer on this page than I think here. Return return from subroutine. Yes. Yeah, return from subroutine pulls the 2 bytes of the stack and transfers program control to that address +1. And that is because jump subroutine doesn't increase it enough because of how the hardware is built. So this explains why this +1 is here, and that's why we don't need this comment. But, you know, we can comment something like or we don't need to comment anything. Yeah. So let's see where we went off. I remember there was something else with pushing and popping that we kind of messed up last time. So line 104. So here we have push a, PHA. Stack instructions. These instructions are implied mode, have a length of 1 byte and require machine cycles as indicated. Okay. Yeah, what was it? PHA? Push accumulator, yeah. This was 48. So we push FF onto the stack, and then the next instruction, PLA. Oh, it's right here. Pulls the accumulator. Does it have any more description to it? Oh yeah. So should we even set flags here? We should set the 0 flag and negative flag, which we do. Yeah. I mean, this looks correct. So what is incorrect here? The P. The flags are incorrect. Let's get our handy little calculator. And we wanted EF, which is this. So what was this flag? Flags. This was the B. Okay. CPO, the value pushed on. Oh, on what cost? Note that the flag does not represent a register that can hold a value, but rather a transient signal in the CPU controlling whether it was processed and interrupt when the flag were pushed. Oh, so cause PHP, then the flag is 1. Okay. So, if I understand this correctly, this is PHP and the PLA. What? Okay. 6502 B flag. No actual B flag exists. Yeah, we read this. The B flag only exists in the status flag byte pushed to the stack. So I guess there's a comma, software interrupts. PHP will push the B flag as 1. What does that mean exactly? I'm not getting. So our mistake is in 104. After PLP, the flag have changed. After PLP. Oh, and it pulls all these from the. So PLP was just wrong. Okay, maybe this was just wrong. Is this the first PLP? Yeah. I wonder if we can. Okay, now we debug test. Does this work? Does it work or not? I'm a little bit unsure whether this was a good idea to put this in a test. I don't know how to debug this. Why doesn't this thing work? Does it if I put... It does work. But I had a... Okay, it doesn't work because it doesn't... The current directory is wrong. Okay, let's just... The file descriptor -100. Oh, maybe this was wrong. So here I'm having test resources, which is in the... It should be in the workspace directory. This is so weird. So if I run it normally, it fails like at 104, and if I debug it, no such file or directory. Oh. So is this... Yeah, this is the... And if I go to, I don't know, something else, obviously it can't find the directory. Okay, so test main. That's so bizarre that it doesn't work. Huh. Okay, that's just minus 100. Sig print current working directory. Is there something like 2path? Okay. Oh, log is where is that thing? Allocator. Okay. Oh, init is not a function. No. This is a function. Okay. Okay. Yeah, this is a try. And this returns a U8. What's wrong? Oh. This whole thing needs to be wrapped. Yeah. So if I okay, so it's the source is the current working directory when I debug it, but not when I run it. That's really bizarre. But anyway, sometimes things like this, like, okay, this really needs to be improved, but whatever. If clicking debug here puts me in the wrong directory, then yeah. Okay, so a CPU has these flags, AD, and after this operation the flags change. FF. Yeah, because we had... Okay, how is it? We had FF. Now we push H to the stack. We pull the stack into... We pull the stack into the status register P, and what I don't understand is why we want EF, and I think now we know why, is because we have FF, okay, but this B flag should not be set because it is only set in certain conditions. So now my question is, if we push it to the stack, is it already cleared? Like PHA. Okay, my question is, if I push the accumulator to the stack, the register A accumulator is FF. Will FF be on the stack, or will it already have the B flag cleared? Or will FF be on the stack, which I think makes sense, but when you pull it, B flag, let's read that again. Mm-hmm. When the stacks are restored with PLP, the B is discarded. Okay, that's all we know. That's all we need. Okay, so CPU.flags dot B flag equals false. That took so long for me to understand what that means. But yeah, from now on we need to run it from here because I hacked this into this thing. Okay, let's remove this for now. Finally, finally, an unimplemented opcode. 09. Right here. What is it? Logical inclusive OR. That sounds very inclusive. I think we will have this close to the we already have an end, I think. Let's just put this here and see what it is. So A or memory. Okay, that is, I think, very similar to the end, except for OR. Line 175. 175. Why is this EE syntax highlighted? Okay, that's very interesting. 175. The P value should be this. Is this? Alright, editing Jan is here. So at this time I was very confused about the add with carry operation, especially the overflow flag confused me a lot. And you know, I played around a little bit, I looked at other 6502 implementations and asked Gemini, but I really wanted to understand why the overflow flag was set in a certain way and how the add with carry worked. Especially confusing for me was whether it is with signed or unsigned integers, but that doesn't matter, is what I learned a little bit later. So I spent a lot of time now understanding ADC. I will speed some of this up or cut it out. Anyway, I will explain a little bit what I did. So the end is relatively simple except for this line. So add with carry is, okay, you fetch 1 byte. This doesn't have to be this can just be the U8. And then you calculate the result. So you have the carry flag, the operand, and the A. And basically I was struggling a lot with this overflow flag, as you saw, because what I kind of missed is I found this really cool page. I will not forget to link it here. But basically what it boils down to is we do a plus with carry, but it is not necessarily defined if the plus is between 2 signed or 2 unsigned numbers. It could be either or. And if we just care about unsigned adds, then we just care about the carry flag, and if we care about signed, then we want to see if the overflow was on. And here they explain this formula, basically saying that basically saying that the overflow is if the sign of both inputs is different from the sign of the result, then the overflow has happened, which is, for instance, if you add, if it's unsigned, it doesn't matter, but for signed, minus 48 plus minus 112 is 96 if you just add it. But here you would set the set the overflow flag. Okay, enough of this. I will just copy paste this. Copy paste this explanation. Where was that? Yeah. Hello. Yeah, and this is basically the sign. I'm thinking about doing let me see the flags. Okay. No, anyway, let's continue. Let's not touch this further. And then I already saw that the next test fails because we have an integer overflow. Yeah. Oh, no, we are still here. I guess we have to do this. Yeah, line 265. Nice, we have another add carry. Here this time we expect it to be 27, but we found 26. So it's obviously this, which is the status flags. Do I have this in the description, by the way? Not description, I mean like readme file. The carry was wrong. Okay, we just check if the result is greater than, yeah, I think. No. Should it be greater or equals? No. FF is fine. No, wait. We're line 265. No, it was correct. Okay. P. We found 26. We add 80 to. So 80 should be 128. And we add it to 7F. And then the carry flag was also set, I think. Carries, so it's, if it's odd, the carry is flat, is set, right? Yeah. So now we add, and this becomes 0, which should mean that the carry flag is also set. Okay, let me see. It was this one, right? No. This one, result 0. Why is the result 0? If we add, I mean, A was 7F, operand was 80, this was 1, so result, oh, wait, no, I'm stupid. I think what I have to do is this. So it didn't matter that we had U16 here because we were on this side wrapping. Yeah. Okay. We have something else. 260. Compare fails because this should just wrap. I think probably maybe it should also set some overflow flag. Oh, unimplemented. C0. This is compare Y register. What was it? C0. Yeah. C0. There's probably also compare X register. Yes. And that is E0. All right. So the immediate mode, of course, is fetching a byte and then comparing it here with X and Y, and then also setting the flags. No, wait, this is X and this is Y. E9. Subtract with carry. That was E9. Okay, this should be quite similar to add. Where is it? Add with carry. Subtract carry. Let's see. Integer overflow. No. 498. One minus carry, so this means plus carry. No. Oh, so this should be the other way. C8. Okay, last instruction for today. I guess that is arithmetic. These two. And maybe we also do increment x. E8. And then there's also inc, which is the accumulator, I think. Oh, this is 0 page. Increment memory. Okay, I would say okay, line 500. Not too bad, not too bad. Okay, I would say let's leave it at that for this episode. In this episode we did a few instructions. The most difficult for me was to figure out how the overflow works in the add with carry and subtract with carry, but I think now I understand it better. And yeah, that's really cool. Okay, see you in the next episode. Bye.